In this video, I'm going to show you how to set up a Go API using some boilerplate code. This is supposed to be introductory, not really showing you much about Go, but like just some code that you can use as a great starting point. I'm going to use this as my starting point in a lot of my other videos, so I just want to make a video around it so it's very clearly laid out. I'm making some assumptions here. I'm assuming that you have Go on your computer. I'm assuming that you have Mongo. It uses Mongo as its database layer. Not hard to switch it out. You can use something else as well. Just as a starting point, it uses Mongo and Go. I'm using Go version 1.14. This whole tutorial is actually in written format if you're looking to move fast, and I've linked to it down below in the description. It's exactly what I'm going to be talking about right now. Just easier to copy and paste. Essentially, what we're going to be doing is this Go Boilerplate code, which is linked out on GitHub, and so you can find it here, Keith Weaver /Go Boilerplate. Please star the repository for using it, just so I know you're using it, and then fork it if you want to make changes and have your own copy of it. This code here is structured in a more Java than actually Go approach. So it has handlers, models, repositories, and services, as you can see, all listed here. Handlers being more handling the inbound requests, so this would be like your HTTP request. Models being used across the whole set of packages. Models being like dumb structs or classes. Repositories being your data access layer, so this would be any calls going out to the database. And lastly, services, which is the majority of the business logic. Essentially, it expects a set of arguments, and then essentially will return back the output of that logic. And you can kind of even plug and play like different things. So if you're using HTTP requests, you can eventually switch to streams and use the same services methods. We also have the main.go that essentially declares everything, sets up the endpoints. There's the auth method in there as well. I'll go through all that as well. Start by just downloading this. So just hit download zip. Unzip it, and then I'm just gonna work right off my desktop here. So just open up desktop and then just go. I'm gonna call it Go Demo. I recommend you can use an actual Git project and everything else, but I'm not going to. I'm just gonna copy everything and just drag it right into that folder. After that, we're good to go. Next, we're gonna be just opening this up in an editor, just so we can kind of go through it and I can explain it as we go through. I'm gonna be using GoLang here, so I'm just gonna open the project up. So I'm just going to open project. Desktop, GoLang. Okay, before we start going through this, I'm just going to go back to my written tutorial and just like make a reference to it here so we can understand. So pretty much in this boilerplate code, there's two parts. There's user-related methods, and there's a CRUD-based thing. So CRUD is, I'm using cars as an example. So I provide you with essentially the basics of list, get, create, delete, update, all around the idea of a car. I'm just using that as some sort of example because most things that you're going to build often are CRUD-based things. And then on top of that, you need sign in, sign up, and log out because you want some authentication around that. This sign in, sign up, and log out is really rudimentary. I even highlight there's no password encryption or anything like that. Like just use beEncrypt. There's a lot of options, and I'm coming out with another series at the start of next month that is all about around building out a better login system. This is just to get you started. So then, essentially in the tutorial here, and we'll do the same, is we're going to start by going through the main function. We're then going to go through the handlers. We then move down into the services where I explain the logic, and last the repositories, and then models. And I'll kind of jump between models and throughout. And so that's kind of how I've laid this out. So let's get started. Let's start in the main. In the main.go, the first thing I'm going to say is actually scroll all the way down to the bottom. And the reason why we're going to do this is because these are the two main, these redder groups here are the most important. So these are the endpoints that we're using. So as mentioned, we have user, so /user/sign up, /user/sign up, sign in, /user/logout. And then we have cars slash, and which returns the get all, and then a specific ID, creating a car, updating a car, deleting a car. So these are our endpoints, and we'll go through each one. We have the health endpoint, which is just at the root of the project or at /health. We have this middleware function. I'll show you it's above. Here we have where we declare each one of our methods. So repositories, services, handlers. And if you think about it from a inherit standpoint, this is why I use this approach compared to often Go project people use like a package model, which works great. I'm more comfortable with this approach. Handlers inherit, handlers use services, services use repositories, and then models are kind of used throughout it. So models in this case is your bottom layer, and then you have repositories, and then services, and then handlers. And it creates this nice import cycle that doesn't ever run into each other that often. So I know where all my models live, and often when something goes wrong, I can easily find it. That's why I really like this approach. Now, I also have my DB package here, which is everything related to the database. It's fairly simple. I can actually open that up first. It just creates a connection to the Mongo instance. It's running on my local host, no username, no password, 27017. Obviously, if you go in production, add a password, add a username, make this like environment variables and things like that. But this is just the basics. Moving back to my main.go, we're going to keep scrolling up. So essentially, they all, repositories takes the DB instance. Each service, the car service takes the user repository and the car service repository as input. The handlers just take the services as their input. Here's my database name. So scrolling up, here's my middleware. So like if you're using a front end, you would change this to be your website. And lastly, this is the validate auth method that's also in this main.go file. This can absolutely be moved into another method, but I just left it in here because it's really, really short. What happens is, as you call one of these endpoints, these are all the endpoints around the cars and cars group, essentially. You call, what happens is it goes to the validate auth middleware code first. It then goes to the cars get all here, and then it returns back to the validate auth. So scrolling back up to the validate auth, takes the user's repository, because it has to do a database lookup of whether or not the session exists. So it grabs the auth token, which is also like the API key or a session, from the authorization header. It pulls out the bearer, and then looks up for that session. If it's not found, it returns 403. Anything goes wrong, it just returns a 403. And then lastly, it sets the session in the gin context. This is just to save an extra API call. We can just pull it out of the context. And it is c.next, which is gin-context.next, which then allows you to continue on to the next level. So in this case, in the case I showed you before, that would be the cars.getAll. And that's pretty much the main.go. It's the highest level. It's the method we call to start running all this code. We're going to start next going into the health handler here. So this is just really, really simple. It just returns a 200 and just says healthy. It's a basic JSON response. Just allows us to do a check to see if our API is up. Next, we can go to user handlers. Again, creates a new instance of this user handler struct. It only has one attribute, which is the user service. So for example, here's the sign-in method. So it grabs the request body and binds it to this struct here, which is the email sign-in body, which is email, password. It's expecting like the JSON in with this format. It does validation against it, and then it calls the sign-in service. The sign-in service comes back with a token or an error. Show the error if it's an error. Show the token if it's a token. Sign up, relatively the same. The only difference is there's a name attribute. Sorry, and that I should mention, this keeps opening up models and then users or user. Yeah, and so validate, and then call the sign up, which is the same thing. Return the token if it comes back. Last one is logout, where it just passes in the auth token, so it signs the user out based on their session. if it errors, show an error. If it works, say logged out and give them a 200. So next we're going to go into the cars handler. As mentioned before, there's get, list, create, delete, update. So starting with actually list, which I call get all. It grabs that session. And then essentially it allows for optional query parameters. So two that are not specific to cars are page and limit. Page is for pagination, which allows us to control how much data they're pulling into the database. In a simple example, if I have 100,000 cars and someone says get all, I don't want them to actually return all 100,000. It would really tank my server and all my databases. I want them to be, I want it to be paginated, so they can load 25 of them at a time, and then they can iterate through and only see so much of it. The other side of it is make, model, and year. These are all optional fields for filtering. So make, it pulls up the car make, model, so I guess that would be like Mazda. Model would be like, 3 for the model of the car, and then year would be like 2015, for example. Next, we want to convert the ones that are supposed to be numbers into numbers. So year, page, limit are all supposed to be numbers. And then we build this query parameter, which makes it easier to pass this throughout the throughout down to the service. We just want to pass this nice struct containing all the information, do some validation, and we pass it down to the car service where they have a get all method. We pass the session and the query. What we get back is a list of cars, if it's not nil, and then an error. So if it's an error, show the error message. If it's nil, the cars and it's not an error, provide an empty array, and then return cars, the list of cars with a 200. Similar to, so moving on to the next one, this is the get by ID, which is, it leverages, I'm going to jump here. This is get by ID, where it actually leverages cars ID, which is coming from a parameter. I'm going to jump back to my main.go, scrolling down. As you can see, I have this little notation here for path parameters. So that's where this is pulling from. So uses the gin context.param and it pulls out the ID. So this is how I'd pull out a specific car. So I pass in, it uses the Mongo document ID. So it just passes in the session and then the car ID. It will return the specific car and an error. Same with, so then create is similar to sign in or sign up with the post request. It takes a request body in JSON format and then maps it to a struct, validates it, passes it into the service. Same thing here. So update, similar idea, grabs the ID from the parameter, grabs the JSON request, validates it, passes it down into the service layer. Delete, it just grabs just the parameter ID and then passes it down. So that's the majority of the car handler. Again, if you're going to, using Airbnb as an example, if you're going to build a marketplace, with hosts or places to stay, it'd be the same thing. You want to be able to create a place to stay. You'd want to be able to update it. You'd want to be able to delete it. You'd want to be able to list a whole bunch of them. You would want to be able to list this individual one. Same idea. That's why I use cars as my simple example here. We're going to move on to the services layer. We'll start with the cars services because I've begun to go down this cars path. So again, get all is really, really simple. Like after you build that query, it just passes it right off to the repository layer. So we can go into that actually. Same with the get by ID. The create builds out the actual car struct. So it takes the body and says, plug in the make, the model, the year, and then throws in some defaults. So it adds an email. So like you can map cars to users and you can figure out when it's created. And then the idea of a status calls the repository layer as well. Update, same thing. Like these are all like extremely simple methods, right? Same delete, just pass through the session email and the car ID. And so with that, we'll continue down into the, we'll skip over the user services and we'll go right into the cars repository because that's where all the logic really lives. So here's the list to start off with. So again, takes the database as an instance, a pointer to the database, and creates a cars repository where it has one attribute, which is the database. So it has this filter method. Filter here is actually lives inside of the cars model. So, and it references, so here's list car query, so page, limit, make, model, year. We've seen this before. And then builds out the filter for Mongo. So we want to start by saying we only want to show cars that are owned by that user. So that's where this email attribute comes in. And then we want to go through here and say, okay, so if they have set make, the make of the car, we want to grab the make or anything similar to that make. So in this case, with the regex here, it's just saying, if I, for example, we'll go back to my Mazda example. If I type in MAZ, and I haven't typed in the DA, for example, yet, I want to still return that because they're beginning to type that in. Same thing with model. If it's an exact match or similar to, year is not the same. It's just like, if I pass in 2016, I want the 2016 one back. Like there's no 201, like you'll get too many results. And then essentially it's just a bunch of and filters. So, so email and make and model and year only if they're all set, and then return that. And so that will set return. So that's our filter. Next is the limiting. So we just pass in like set limit, and then we do skip, which is query parameter dot times limit. So in this case, page is 1 times the limit, which is 25. And then you want to subtract 25 because if you're on page 1, you actually don't want to skip any. You want to start at position 0. If you're on page 2, this would be 50 minus 25, which is then you want to start at the 25th position, which is page 2, and so on. And then you want to have some sort of way to sort it because you want to make sure you're getting the data back in the same right way every single time. So in this case, we just use created as the easiest way, and so we want the newest first. It does the filter, and then it maps essentially builds that car model struct and maps it back into builds a slice of them, and then returns that. That's pretty much the list method. Moving on to the get. These are all going to be pretty simple now. So like, for example, this is just like the document ID and the email, and finds one and then maps it, maps the response into the car struct. Save car, same thing, where it just like, if you look at car, the car object here, we have the bison tags, which essentially knows what the naming is. So it uses that as the attribute fields. And I actually realized that's a mistake. There shouldn't be a comma here. It should be a space like that. Yeah, like this essentially. But they're all lowercase, so it won't actually affect it. It actually defaults to be lowercase like that. But that's actually how it should be. I think I posted a fix for that. Anyways, so that's the save. You get the response back, but we're not passing back the car ID, but if you wanted, you could pass back the ID. Same with update, build an update. So a set query parameter. So in this case, we want to filter by ID and email, and then we build an update method here. So if make is set make, and then we just use like a set method, which is Mongo. You can just Google. So here's the set method on Mongo reference, Mongo code. So again, it looks like this, where it takes the ID and then you set it, and it'll update the fields. So quantity will be set to 500, and so on. It's all pretty basic Mongo queries. And last is delete here, where it just deletes one, takes the document ID, converts it into be an object ID type. It filters so you can only delete that specific document, and you have to be the one who owns it, and deletes just the one. If there's an error, it returns the error. Otherwise, it returns nil. Okay, so with that, I'm going to move on to the user service. I'm flying through these, and I know it. It's more around time for this project. I'm going to actually circle back into more depth in a second once we get testing this, and I'm showing you how it kind of works. The user service is a few methods. It matches what we had before with the handler. So sign up, sign in, log out. So I'm just going to close them so you can see them all. Is validate password, get encrypted password, and log out. Sorry, not log out. Is validate and get encrypted password actually shouldn't be public methods. So based on the capitalization, they are declared as public, but they actually shouldn't be. There's actually no encryption here, so you have to add it yourself. The purpose here is not just to be a starting point, but you can just use like beEncrypt. I can link to it in the description. So we'll start with sign up. So the sign up method is pretty simple. Remember, we're passing in this sign up body where it's an email, a password, and a name. So it takes the email, it drops it into lowercase, it trims off anything on the ends of it just in case. So then the first thing we do is then we want to validate against the password. So we have this is valid password method. I've added to do here. Essentially, you have to add essentially a way to validate the password meets your password requirements. Since mine are is length 10 and or is at least length 10 and is at least has 3 special characters and things like that. I'm just gonna change that to be return true. For now, this is like not recommended at all, but I'm just gonna do it so I can show you get this running. So after you validate the password meets requirements, you've fixed the email to be properly formatted. You want to check to see if this email actually exists. Does this user exist? I like the idea that if someone signs in with the right email and right password, even if they are in the sign up form, to just sign them in. So if the user exists and it doesn't throw an error, and they have the right username and password, just sign them in. So we call the sign in method. I'll go through that in a second. Otherwise, if the user doesn't exist, begin to sign them up. So we built this user model here where we have an email, a password, a name, and a created timestamp. The password here is get encrypted password. So as you can see, it's not set. It's not returning. We're actually storing a plain text password. Do not do this. beEncrypt is a super simple package. I just haven't included it here yet. Again, start of next month, I'm coming out with a tutorial on. Sorry, I just lost my spot. I'm coming out with a tutorial on how to actually integrate all this. I didn't include it in this boilerplate code right now, just simply because I want to make sure that I have it all hashed out. So, but I'm kind of passing the back over to you. So if you actually want to do like SSO or something like that, you can do that as well, or you can figure it out. I just don't want to take that responsibility yet in terms of how to do it. So yeah, stay tuned for that tutorial coming out start of next month, essentially. Jumping back to the code here. So it signs the user in, and this sign in method is used on both the sign up and sign in. It's kind of confusing with the 2 sign in methods, but one's capitalized and one's not. I want to do that kind of on purpose because sign in is what you're doing. If you look at the sign in method here, before I jump down, it just formats the email and then passes it through. It's really simple. The reason is in both cases, sign in and sign up, you both want to sign them in after they've created their user. And you don't want 2 spots for all this code, right? Like after the user sign up, you don't have to rewrite all the sign in code. So you just want to use a common method here. So what it does is it grabs the encrypted password and then it does an email lookup, compares the encrypted password against the one that was provided. Sorry, not the one that was provided, against the one that was stored on the user model object. If they don't match, you just say unauthorized. If they do match, you continue doing, you create a session. So in this case, I'm creating a new session, and I can show you the session model. So we have ID, email, expiry, and created. As you can see, expiry is a day in the future. This is because these were the security requirements I've set for myself. I just want sessions live for a day, and then if you come back to the website the next day, you should be kicked out. Next is email. We have an email there because we want to save a step. So if you think about it with the cars service as an example, every single car has the owner attribute or the email attribute, where it's like this object has, like, we filter by for delete, for example. we filter by document ID and email. If we don't store this email on the session, we then have to call the session and then figure out map that back to a user and then pull the user. So like this just saves just grab the email from the session. Yeah, and then the last thing here is it just saves the session, gets back the token, so that'd be the document ID. If it threw an error, throw the error or bubble up the error, and then return the token. One thing about this whole code base, and I'm going to fix it, it's not really a problem, but is the errors. So some errors bubble up to the surface and it shouldn't be seen by the user. So Mongo, like for example, if this actually threw an error, this is a save session, what you should be doing is logging the error and then returning an internal internal server error, like a 500 or something like that, and not showing the user what Mongo error was thrown. But this is just a starting point, and as you kind of develop with it and run into these errors, you want the feedback. So I kind of left it there, but just be aware. And lastly, the last method here is logout. Again, this is going to be pretty simple. Grabs the session and then it marks it as expired, which is a custom method in the user repository. We haven't gone through this, but we will. It does a filter by ID, so in this case the auth token, and then does an update. And so what it does here is it just sets the expiry to be the current time and kind of that marks it as expired. You can also use some sort of deleted Boolean flag, which is another option. But this would stop anyone from using this session again, because if I scroll up, we haven't gone through this, but if you look at get session by ID here, it only grabs the sessions for the documents that are greater than the current. Essentially, if the expiry is in the future, then it's valid. Yeah, and so that's the update here, and then get session by ID grabs the current ID, assuming it's not expired. The save session here, again, insert one, it uses, if we click the actual, I'm going into models and then user, we look here and you can see the struct, it uses the Go tags here for the actual naming convention in the Mongo database. Again, I'll show you this in a second. Same with save user. Does user exist is just a get user, and then if it does exist, it just returns a Boolean instead. And I'll go through all these methods kind of as we test this out. So here's the moment of truth, is actually testing this all out. I should note that there's going to be one bug that I actually find in this video. I do resolve it. I do show you how to resolve it. The only reason why I haven't simply just removed the video and re-recorded it is, well, kind of the time commitment, and it's a really small bug. And it's good to see why some things can go wrong and how to debug them, because I'm sure that you'll run into it again. So I just left it in there. Just a fair warning as we continue through this. I'm just at the end of this and realized that I ran into that. So let's get it running. I just want to explain it all again in more depth. If that was enough, you can. So the first thing you do is open up your terminal, open up the project. So for me here, I'm on my desktop. And I'm using Go version 1.14. I have Mongo on my local machine and it's running. So I actually recommend using Mongo Compass here. And as you can see, the API got started. I have my two health endpoints. I have my user endpoints. I have my car endpoints, and it's sitting on 8080. Going back to my Chrome here, I'm just going to go in and type in localhost 8080. As you can see, I get healthy as my response. So that's, and then we can head to our terminal and we can see the call come in here, and it gets response is 200. Fave icon is 404. That's fine. So the next thing we're going to do here is we're going to go through all the commands. We're going to sign up a user. We're going to log them out. We're going to sign them back in. We're then going to call the cars endpoints, the create, the update, the delete, the list, the get, all of them. I'm going to pull a number of commands from the README, Now this is, they're all listed in here, and we're going to be really going through and modifying the auth token in most, and often the ID. It can get a little bit confusing. Important things to just take a look at are the request method type. So it could be put, delete, get, post. The data, the raw data body there, which is just the request body. Taking a look at that as well. And the last one is the ID, essentially the URL. So it'd be like /cars/the ID, and you have get, and it's pulling back that specific car using that ID. All these commands are in the README. I'm gonna go through them all. I just do a little bit of jumping here, so just fair warning. Feel free to pause the video. I try to slow down, and I'm not gonna go through. I'm gonna circle back and try to go through parts of code, but I may not go through the code in super amounts of depth. So feel free to ask questions in the comments. I read them, so I'll answer anything as they come up. So let's do that. I just want to check to see if I included curl calls in here. I think I've added them in, but okay, yeah, so I did. We're not going to use Postman just because I don't want to mess around with Postman. So we're going to start with sign up. So this request is going out to localhost 8080/user/signup. In terms of headers, it just has content type. There's no authorization key. In terms of data we're passing is the email and the password. And so I'm just going to copy this command. I'm going to open up a new tab here and paste this guy in. I'm going to hit enter. As you can see, it returns me back a token. So just for logic standpoint, I'm going to go back to this page here. I've dealt with this, but it's just showing it just for because I didn't actually remove the printout. So called the signup endpoint. I'm gonna open up my Mongo Compass here. Mongo Compass, you can go to the Mongo website and download it. I didn't explain this at the start. It's just a great way to visualize. It's an Electron app. It's just a great way to visualize your data, see it. So here, this would be the same endpoint that you're connecting to before. So it comes with no sign in. Okay, so my Mongo Compass is now opened. I had to delete a database that already existed, so I can better show this example. So I'm just gonna make that same sign up call again. So ignore this one. I'll actually hide it. I'm just gonna hit up, hit enter. Now I have my token. It's called sign up again. So let's just like see this. So I'm just gonna refresh my Mongo Compass. So there's demo DB here. It's created one user in one session, which makes sense. Let's see that user. So we have email and password. Passwords in plain text. Do not do this. Use being encrypt. Literally just Google it. It's a full written. Here it is. Here's another example of it. It's super simple for encrypting passwords. Again, I don't want to include it in this example. So here, like, get your hash password, check the password hash against is it a match, yes or no. So it'd store like this instead. Is it a match? Yes. Like I'll include a link to this tutorial in the description. So back to my Mongo Compass. So I have my user, email, password, and then if you go to session here, you can see the email matches up, and then I have that same session here. Expiry is tomorrow. So today's the 31st of December for me. So tomorrow in 2021, it'll be expired, which is kind of cool. Yeah, so we're just gonna head over to, so that was the sign up. So let's try out the logout command, or let's actually first head over to the code here. So if I went to my user handler, what happened here, it went to sign up. It then added the sign up body, went into the user sign up service, made everything lowercase, trimmed it, validated the password met requirements, checked to see if the user existed. User did not exist. It then signed up the new user. So for example, name wasn't set. And when something isn't set in in Go for the string type, it just sets it to be an empty string. It just returns my encrypted password, which is my plain text password, and then save that user. It then signed the user in. So grab the encrypted password from converts that plain text password into an encrypted password, grabs the user object, compares the two, and then creates a session for a whole day in advance, saves that session, and returns the token all the way back up. So it just went through all that code just for that sign up method. And so let's try the sign out, the log out method now. So I think my README, go back to my README here. Not sign in, I want to try the log out. And this is actually going to require me to grab this token ID here and paste it in here. So now I'm going to do a post request to my user/logout, the authorization header with bearer, and then my token. So jump here, I'm going to hit enter a few times just to make sure it's clear. And the data, the request JSON, so this right here is empty. There's nothing required. Get back the message log out, which tells me that it went through. You can see the 200. And so this was originally expiring in 2021 on January 1st. And if I just refresh this, it still does. It did not change. Why is that? Okay, it did not change, and I know why here. This was an older tag on my GitHub repository. Essentially what is going wrong here, and sorry, I'm going to explain it, and I'm not going to edit out the error because I did screw up here. If I go to my user repository, so again, same thing, it should be going through, but if I look at here, my auth token here is a string, while the actual data type here is an object ID. So similar to our car example, we need to do a conversion into a document ID here. So this would be my auth token, and it would just returns an error. So I'm just going to modify that. So just add these 3 lines here, and it returns a document ID. And sorry, this is failing because error's already been declared. So I'm just going to remove that. So now it just updates the error attribute. Okay, so I'm just going to save that, head back to the terminal, and just restart our server and try that same command again. I'm just going to hit up, and it says log out again. This time I'm going to refresh it again. There it goes, 2020, 12:31, and then it's 2:47. This is UTC time. Yes, and I should apologize for that. I mean, I could remove the I could pretend that error didn't happen, but these are the things that we get with development when we're testing things out. We get weird errors that we may not have noticed before. So I'm just gonna leave that in there because there's no reason to remove it or pretend it didn't happen. Okay, so that's the logout command. So that same thing went through and just marked the session as invalid. We're gonna head back in and we're gonna go try the sign in. So I have the sign in command here, user/sign in, and then you pass in just the one header, the email password. Well, let's actually try it with an incorrect password. So it's 123. Let's make it 1234 124 instead. And I'm just gonna go back, clear this, and then I'm gonna paste that in. So this should say 43 access denied or unauthorized. And this comes from user handler. We're calling the sign in method this time. Sign in, so it goes through all this code, goes to the sign in, goes to the sign in method, grabs the user, and then it returns this method here where the password does not equal the encrypted password. And so just to confirm, there's no new sessions created. But if we go back and change this command to be 123 instead of 124, it should then go through and create a token and go through that sign in code again. And it's there. So I have a new session token. This time we're not going to log it out because we know the logout works. we're going to try this whole create car stuff, the create car endpoints. So the first one is going to be create car, so we need some in the database. So I'm going to change this to update the token. You have to be authorized to use it. So for example, this one does not exist. So I haven't updated this token. This is an old token, should say access denied. This would just show that the validate auth works. So I'm just going to hit enter. I didn't get a response. I don't know why. Yeah, so I got a 403. So I didn't get a response because it just threw a 403. And that 403 came from that main.go file. Just scroll up here. So that's why I didn't get a response, right? It says it's right here. And when I look here, where's my oh, sorry, yeah, again, not found. So this logout is coming from right here. So that session's not found, which is true. It's the older one. I'm gonna go back here. I'm going back to my README under the create car, and I'm gonna grab my session from previously. That's my create car one. Sorry, grab my session. I'm just gonna update it to be updated, and now this should work. We're gonna clear this. Okay, so this shouldn't work. Yeah, year is missing, the data attribute, so that's where the validation comes in. So I'm gonna add a year. So let's change this to be 2017. And I have to change the token. So car created. If I head back to Compass, I should now see this car. So if I refresh here, you see my new session, but I refresh the page. I just did a Command R because it doesn't always refresh. As you can see now we have cars, and it has object ID as the make, the model, the year as an integer. You can see who owns it. You can see when it was created. Just gonna clear this, or yeah, because we didn't get any information back there. Head back to the I'm gonna head back to the README here. We're actually just gonna skip over the get car because actually I don't know what car we have since I didn't get an ID back or anything like that. So I'm just gonna go and like list all my cars out. So I've updated the authorization token again. I'm just gonna be calling get request at /cars. And as you can see, it's not nicely written out, but this is JSON coming back, so it's an array of cars. I didn't mean to click there. It's an array of cars, and I can see my ID here, and it returns Mazda and 3 and who the owner is and when it was created. So now I can scroll back up and get the individual car. So I'm gonna update the car ID and the authorization thing. So get and then /cars and / the ID, which I just got, and it should return the individual car. So clear. Yeah, and to return the individual car, same thing. We can try deleting this car. Well, I'm gonna try updating it first before I delete the car. So I just need the authorization ID. I'm gonna update that. Sorry, I realized you should really write these down elsewhere, but and then the car ID, and I'm gonna change the year to be 2018. And this time it's gonna be a put request with the car ID, update authorization, and then my contents of my update request only has a year. So the only thing that should change is the actual year. So it says updated car. I'm trying to head back over to my database to confirm. So it says 2017. I'm gonna refresh. It's changed to 2018. The model and the make haven't changed, so that's all working as expected. Yeah, and so the last thing I'm gonna do here is delete. So I need my authorization token and I need the car ID. And I'm should plug that in. So this time the request is delete. And that looks like it's going to break because something's wonky there. No, it's just my screen. Paste that. And so it says cars deleted. Head back to Mongo Compass. And the data is empty. I realized I didn't go through any of the code as I went through all those examples. Again, it was very much basic CRUD operations. So status is not set. So if I went to go do the create command again, I should be able to update just status. Let me just find create car. Let's recreate the Mazda. So recreate the Mazda there. This time I'll just grab the ID from the database. Let's scroll down to update and change status here. Let's pretend this is an auto trader essentially, where buy and sell used cars. And let's say the car is now owned. Now it says owned. Again, this just goes through all this code here. So in this case, update, it just goes through the update method, grabs the document ID, and it does update car.update function. So update car, since status was set, it then sets the status in the update and does a set. That's pretty much all this code. This is all just boilerplate code. It's all just to get you started. Let me know if you have any questions. This is my first video in a while, so I appreciate any feedback. I do read the comments. I'm going to be coming out with a new video every single week, so please subscribe, and thanks for watching.